Hello friends, welcome back. So now we are going to start the last type of problem of finite state machine, that is type 3 problems. Let's get started. So the question which is given to us in type 3 problem says, design a FSM to output the remainder when a decimal number is divided by 3. We all are familiar with this problem, because the first type of problem in type 1 that we studied was design a FSM in which the input is valid if it is divisible by 3. Now type 3 problems are actually going to be very simple, because everything of it, almost 95% of it, is already covered in type 1 and type 2 problem. The type 3 problem are specifically invented for the machines to give some outputs other than yes or no, accept or reject. So if I say this FSM is going to output me the remainder, we all know that whenever we are going to divide a number by 3, the possible remainders are going to be either 0 or 1 or 2, right? So let's say if a number like 33 comes to us, the output of this finite state machine should be 0. If a number like 12 comes to us, since 12 mod 3 becomes 0, the output will be 0. Whereas for a number like 7, the remainder when divided by 3 comes out to 1, and the output of the machine is going to be 1. So on and so forth. So the transition table for this type problem will be created exactly like the type 1 problem. So without me explaining it, I will directly redraw the table now. So over here we are going to consider the remainders, and we all know remainder is 0, 1 and 2. So this is the table that we have for a finite state machine to check if a number is divisible by 3. Now how is this problem different from the previous one? The question over there was asking us to check whether it is valid or not, whereas the question over here is not asking us for a validity of the input. It is simply telling me, be it any number, you tell me what will be the remainder when I divide it by 3. So we are not going to have a final state over here. Instead, in the machine function, what we'll be having is the remainders to be thrown as the output. So let's get started with the machine function now. So this is my state function. Now what is the machine function going to do? If I observe the state function over here, I see that QS on receiving input like 0369 goes to state Q0. We all know that whenever it receives a number like 0369 and it is going to state Q0, every time a number goes to state Q0, the remainder is of course 0. Therefore, the corresponding entry for this in the machine function will be 0. Similarly, the corresponding entry for Q1 is a state which gives the remainder as 1. So the corresponding entry for this will be 1, and the corresponding entry for Q2 in the machine function will be 1, right? Going ahead, I have Q0, Q1, Q2. So everywhere I get Q0, I'll be writing the remainder as 0. For Q1, the remainder will be 1. For Q2, the remainder will be 2. So let's replicate the same in the machine function. So for this row, I have Q0, Q1, Q2. So the remainders will be 0, 1 and 2 respectively for this machine function, which says given a state and an input, what is the output? And in this case, the output is going to be nothing but the remainder. Similarly, for this Q1 state, I have Q1, Q2, Q0. So the remainder will be 1, 2 and 0 respectively. So I have 1 over here, 2 over here and 0 over here. Lastly, for Q2 state row, I have 2, 0, 1 as the remainder. So that completes my machine function for it. Now, as I told you, 95% of the problem is same. So we observe that the state transition table was same. The only difference was there was no final state. The machine function is almost the same. The only difference is we do not have a yes or no. We have the remainders as the output. And now the last thing which is left to be shown is the examples. Now examples over here are going to output the remainder. Let's get started and see how it works. So let's take a number like QS on receiving 1, 2, 6. This is a number divisible by 3, so we all know the remainder has to be 0. So QS on receiving input 1, coming back to the state function, QS on receiving input 1 goes to Q1. So I have my Q1 and what I have left with is 2 and 6. Q1 on receiving 2. Q1 on receiving input 2 goes to Q0. So I have Q0 and a 6 left with me. Q0 on receiving 6. Q0 on receiving 6 goes to Q0. Okay. So it is going to state Q0, and if I observe the circled cell for the input in my machine function, I see over here that it has to output 0. So therefore, QS on getting this is going to finally give the output as 0, or rather I will say the remainder over here is 0. Clear with this? Similarly, you can solve n number of problems and confirm are you getting the perfect remainders. So that completes our type 3 problems. See you in the next session. Thank you.